Welcome to Spot Podcast, the voice of scientists, where groundbreaking research meets your ears. We bring you the world's top-cited research articles in an engaging podcast format, making cutting-edge science accessible anytime, anywhere. Stay informed, stay inspired. This is the Spot Podcast, the voice of scientists.
Welcome to the deep dive. You ready to go underground today?
Always up for an adventure, especially one that could help us solve the clean energy puzzle.
That's the spirit. We're talking underground hydrogen storage, a potential game changer for making renewable energy sources like, wind and solar more reliable.
Yeah, because like you always say, the wind doesn't always blow and the sun definitely doesn't always shine. So what do? We got to store that energy for when we actually need it, right?
Exactly. And that's where our deep dive today comes in.
We're diving deep into this awesome review paper from the International Journal of Hydrogen Energy. It's all about underground hydrogen storage, like everything you ever wanted to know.
Authored by Dawood Zafar, Sunil Kumar, and Jalal Farouzish. A pretty impressive trio. But before we get into the nitty-gritty, let's answer the big question. Why hydrogen? What makes it such a promising energy carrier in the first place?
Well, one of the big things is its energy density. Hydrogen can pack 2.5 to 3 times more energy per unit mass than natural gas. Crazy, right?
Wow, that's a lot. Okay, so what does that mean in real world terms? Give me an example.
Okay, so picture this. A car running on hydrogen. You could potentially drive way farther on a single tank compared to a gas guzzler. I mean, that's huge for things like, trucking or even airplanes where weight and how far you can go are super important.
Okay, I'm starting to see why everyone's so excited about hydrogen, but I'm still a little stuck on how we actually store it underground. I'm imagining these massive, underground tanks, kind of like the sci-fi movie.
It's actually way cooler than that. We're talking about using what nature already gave us. Existing geological formations. Think of them like giant natural containers that have been holding gases safely for millions of years.
So nature already did all the hard work for us. I like the sound of that.
Exactly. And this paper lays out 3 main types of these underground storage superstars. Depleted oil and gas reservoirs, aquifers, and these awesome things called salt caverns.
Let's start with depleted oil and gas reservoirs. It seems pretty intuitive. They held gases for ages, so why not hydrogen?
Right. They're definitely a top contender. They have a proven track record, and we already have infrastructure in place, which is a big plus, potentially making it more cost-effective. Plus, the caprock, that layer sealing the reservoir, it's already shown it can keep things contained, which is obviously super important for safety.
Okay, so safety and cost-effectiveness. 2 big wins for depleted reservoirs. What about aquifers? I always thought those were for water. Can you really store hydrogen alongside water?
It might seem a little weird, but yeah, aquifers can actually be repurposed for hydrogen storage. And their biggest advantage, we've got tons of them all over the place.
So plenty of space for our hydrogen. But I'm guessing there are some downsides too, right? Nothing's perfect.
True. One thing is that we might not know as much about their geological structure compared to oil and gas fields, so you might need to do more exploration, which could mean more money.
The classic trade-off. More exploration equals more cost. Okay, now tell me about those salt caverns. They sound kind of mysterious.
Salt caverns are really interesting. They're human-made, formed in these thick salt deposits. And the cool thing about salt is that it's incredibly stable and secure, almost no risk of leaks.
So it's like a super tight natural container? Sounds ideal.
They're pretty great, but they tend to be smaller than those massive depleted reservoirs or aquifers, so there are definitely capacity limitations to think about.
Okay, so it's kind of like picking the right container for your leftovers. It all depends on how much you need to store and what's most important to you.
Huh. That's a great analogy. And you know what? This paper actually dives into some real-world examples of how these underground storage options are being used right now.
Oh, cool. I always love seeing theory in action. What kind of projects are out there?
There's this project in the UK, the Teesside Project. They've been storing hydrogen in a salt cavern since 1972.
Wow, 1972. That's a long time. Talk about a testament to the viability of this approach.
Yeah, pretty impressive. And there are a bunch of town gas storage projects in Europe, like Germany, Czech Republic, France, that have been using aquifers to store hydrogen-rich gas mixtures for a while now.
So this isn't just some futuristic dream. People are actually doing this. Okay, so we've got these amazing underground storage spaces, but how does the actual storage process work? Is it just pump it in and hope for the best?
It's a little more sophisticated than that. First, you got to choose the right geological formation based on all those factors we were talking about. Then you inject the hydrogen, often displacing existing fluids like water or any leftover hydrocarbons.
So there's definitely more to it than meets the eye. What kind of science and engineering magic goes into making sure everything works properly?
Oh, there's a ton of it. One technique they use is a cushion gas to help maintain pressure and make withdrawal easier.
Cushion gas. That sounds interesting. Tell me more about that.
It's kind of like, imagine a bouncer at a crowded club, keeping the hydrogen molecules from getting too rowdy and escaping. We often use methane or nitrogen for this.
Ah, so it's like a little bit of extra support to keep everything running smoothly. And I bet the science behind how hydrogen actually behaves underground is a whole other can of worms.
You got that right. And that's where things get really interesting. You ready to dive deeper into the science?
Totally. Let's do it. Okay, so we've talked about these huge underground spaces and all these clever ways to keep the hydrogen in check. But I'm thinking there's got to be a lot more science involved in figuring out how hydrogen actually behaves down there in the depths.
Oh, yeah, definitely. It's not as simple as just finding a big container and calling it a day. We've got to understand the physics and the chemistry going on down there.
Well, that's what we're here for. What are some of the key things scientists are looking at when it comes to the science of underground hydrogen storage?
So one of the most important things is something called hydrodynamics. But basically, it's all about how fluids, liquids and gases move and interact underground. And hydrogen, it's got some unique properties that can make things a bit tricky.
I bet.
Yeah.
It is the smallest element, right? So tiny. It just seems like it'd be really hard to keep it contained.
You're right on the money. It's way less dense and less viscous than a lot of other gases, which you might think is a good thing. But actually, it makes it prone to this thing called viscous fingering.
Okay, viscous fingering.
Uh-huh.
That sounds a little, I don't know, creepy.
Uh-huh. It's not as bad as it sounds. Just picture trying to, herd cats. That's kind of what it's like, trying to keep hydrogen moving in a predictable way underground. It wants to spread out, and it flows in these unstable finger-like patterns.
So it's like the hydrogen's a little rebellious.
Yeah.
Going its own way.
Pretty much. And those unpredictable flow patterns, they can actually make storage less efficient. So scientists are looking at things like selective technology. Basically, you use separate wells for injecting the hydrogen and then taking it back out.
Oh, okay. So it's like dedicated lanes for the hydrogen highway. Got it.
Yeah,
What about, are there any other scientific challenges with this?
definitely. Another big one is you have to think about the potential for geochemical reactions. Down these reservoirs, hydrogen can actually react with the rock around it, the fluids, and even get this microorganisms.
Wait, what? There are little creatures living in these storage spaces. It's like a whole little world down there.
I know, right? And those microbial communities, they can actually have a big impact. Sometimes they'll consume some of the hydrogen, which is not good. And sometimes they can produce byproducts that we don't want.
Wow, so it's not just rocks and gas. It's a whole interactive system. This is amazing.
It really is. That's why it's super important to understand the specific geochemistry of each site. We need to know what's going on down there before we just start pumping in hydrogen.
Right, we don't want it turning into something else entirely. But speaking of things to worry about, how about safety? I mean, hydrogen is flammable, right? So are there risks of leaks or even explosions?
Yeah, I mean, those are all valid concerns. But here's the thing. Storing hydrogen underground is actually way safer than storing it above ground.
Oh, right, because of those tight geological formations, right?
You got it, like those salt caverns we were talking about.
Yeah.
That thick salt layer is a fantastic natural barrier. And, the sites are chosen really carefully, taking into account things like geological stability, all to minimize any risk of leaks.
Plus, we've got those constant monitoring systems, right?
Yep, absolutely essential. Those systems help us, catch any potential problems really early on so we can deal with them before anything bad happens. It's like a 247 security system for our hydrogen vault.
Okay, so we're choosing the right location, we're understanding the science, and we're keeping a watchful eye on things. Sounds pretty good so far. But let's be real. How much does all this cost? I mean, underground storage just sounds so complex and high-tech. Is it even economically viable?
That's the million-dollar question. And yeah, underground storage does add some cost to the whole hydrogen energy picture, but the good news is it's still the cheapest way to store a lot of hydrogen.
So it's cheaper than, building those huge tanks above ground.
Yeah. And as the technology keeps getting better and we start doing it more, those costs are only going to go down.
Okay, so maybe it's not exactly cheap, but it's the most cost-effective for storing a ton of hydrogen. That's a pretty good start. But is it cheap enough to make a real difference in how we get our energy? What are the things we still need to figure out to make it truly competitive with, well, everything else?
That's a really great question. I mean, there are some cost hurdles we have to overcome. For example, building the infrastructure we need, things like pipelines, compressors, the storage facilities themselves, that takes a lot of money up front.
And I'm sure the operating costs aren't cheap either. I mean, keeping those compressors running and monitoring everything, it all adds up.
For sure. There are definitely ongoing costs for things like energy and maintenance and monitoring, and those can change depending on the type of storage facility.
Oh, really? How so?
Well, salt caverns tend to be a bit cheaper to run because they're so stable, they don't need as much maintenance. But aquifers might need more frequent monitoring, just in case something's up.
So each type of storage has its own, cost profile. We need to figure out which option makes the most sense for each project.
Exactly. But here's something important to remember. As we get better at this and the industry grows, those costs are going to come down. And we have to think about the costs of not investing in clean energy storage.
Oh, right. I mean, we're talking about the cost of climate change, air pollution, relying on fossil fuels. Those costs are huge, and they're just going to keep getting bigger if we don't find better ways to do things.
Exactly. Putting money into underground hydrogen storage, it's an investment in a cleaner, more sustainable future. It's playing the long game.
I'm all about the long game. But before we get too ahead of ourselves, let's back up a bit and get into some of the nitty-gritty details.
Sounds good. What's on your mind?
Well, we've been talking a lot about storing the hydrogen, but what about, the quality of the hydrogen itself? Does it need to be, I don't know, a certain purity level?
That's a really good point. The purity of the hydrogen definitely matters, and it can actually change depending on what you're planning to use it for.
So not all hydrogen is created equal.
Nope. If you're using hydrogen in a fuel cell, it needs to be super pure. But for some industrial processes, it might not need to be as, pristine.
So how do they actually make sure the hydrogen is the right purity for storage?
There are a few ways to purify it. One that's pretty common is called pressure swing absorption. Basically, you're filtering the hydrogen to get rid of any contaminants.
Ah, so it's kind of like a Brita filter, but for hydrogen.
In a way. And there are other techniques too, like membrane separation and cryogenic distillation. They can also be used to get really pure hydrogen.
It's amazing how much goes into something that seems so simple on the surface, storing gas underground.
It really is. It shows just how creative and innovative we can be when it comes to using natural processes and new technology to solve these big challenges.
Okay, I'm feeling pretty inspired now. But let's be realistic. What are some of the, big roadblocks the industry still needs to figure out to make this a reality? Make underground hydrogen storage mainstream?
Well, one of the biggest hurdles is figuring out how to scale it up. We've seen some really successful pilot projects, but scaling it up to meet the demands of, a global energy transition, that's a whole different ballgame.
Right. It's one thing to store a little bit of hydrogen, but we're talking about storing millions, billions of cubic meters.
Exactly. We need bigger storage facilities, obviously.
Right.
We also need a better, cheaper way to get the hydrogen in the first place, like producing it, transporting it, distributing it. We need a whole system.
So basically, we need to revamp our entire energy infrastructure. That's a pretty tall order.
You said it. And then there's the whole regulatory landscape. Underground hydrogen storage is still pretty new, so the rules and regulations are, still being worked out. We need clear guidelines to make sure everything's safe and to encourage people to invest.
The dreaded red tape. But I guess it makes sense. We need to make sure things are done right, especially with something as important as, the future of energy.
I agree. We've got to find that balance between letting people innovate and making sure everything is safe and responsible.
Okay, so we've got the scaling up problem and the regulatory hurdles. What else is standing in the way of our hydrogen-powered future?
Something that doesn't always get enough attention is public perception. A lot of people still have, misconceptions about how safe hydrogen is. We need to do a better job explaining the benefits and, being upfront about the risks.
Oh, right. Hydrogen has kind of gotten a bad rep over the years. I mean, there have been some accidents in the past, but we've learned a lot since then, right? About safety and how to work with it.
We definitely have, and it's really important to tell people about that progress. We need people to feel comfortable and confident about hydrogen if it's going to be a big part of our future.
For sure. Education and being transparent about everything, those are really important. But even with all these challenges, it seems like there's a lot of excitement building around underground hydrogen storage.
There really is. And, if we keep doing research, developing new technologies, and if governments support these efforts, I really think this could be a game changer.
I love thinking about the possibilities.
Yeah.
Okay, so we've covered a lot, from the science behind it to the economics and the challenges. What would you say is the big takeaway for our listeners? What should they be thinking about as they, go about their day?
I think the most important thing to remember is that underground hydrogen storage, it's a really important part of building a clean, sustainable energy system that can actually work for everyone. It's about using what nature has given us and combining that with human ingenuity to make the world a better place.
It's about having a little hope, right? Knowing that we're working on real solutions to these big problems.
Absolutely. It's about believing that a future with clean energy is possible, a future where everyone has access to it.
I like that. Okay, so now that we've got the details down, let's zoom out and think about the bigger implications of this technology. What can this mean for the world?
You got it. Let's do it.
Okay, so we've gotten into the nitty-gritty of underground hydrogen storage. The different types, the science behind it, the challenges and all that. But now I'm thinking bigger picture. How does all this fit into, actually transitioning to a cleaner energy system?
Well, one of the coolest things about underground hydrogen storage is that it could help us solve one of the biggest problems with renewable energy: reliability.
Right. Because, like we said before, the wind isn't always cooperating and the sun definitely takes breaks. So how does storing hydrogen actually help with that?
Think of it like a giant energy bank. We can deposit excess renewable energy when we have more than enough and then withdraw it later when we need it. Let's say it's, I don't know, a super windy day and all our wind turbines are going crazy, producing way more electricity than we need right then.
Okay, yeah.
We can use that extra electricity to make hydrogen through electrolysis and then store it underground where it's safe and sound.
And then, when the wind chills out or maybe demand goes up, we just, tap into our hydrogen savings account.
You got it. It's like having a giant battery for the entire power grid so we can smooth out those, ups and downs in renewable energy. And, as we move towards electrifying more things, our cars, our homes, everything, this kind of energy storage becomes even more crucial.
Because we can't exactly rely on fossil fuels to pick up the slack anymore.
Yep.
Right? We need a cleaner way to do things, a way that we can actually depend on.
Exactly. And that's where underground hydrogen storage is so promising. It could really help us make clean, renewable energy work for us all the time, 24/7.
Okay, that's a future I can get behind.
Yeah.
So we've talked about all the technical stuff, the money side of things, and now the big picture impact. If our listeners take away one thing from this deep dive, what should it be? What should they be thinking about?
As we keep learning more and the technology gets even better, I think underground hydrogen storage could be a really viable, cost-effective way to make renewable energy the main player in our energy system. It's a technology with huge potential.
It's almost like we're on the verge of a hydrogen energy revolution.
I think that's a great way to put it. And, any revolution needs everyone to pitch in to make it happen.
So what can our listeners do to be part of the hydrogen revolution?
First of all, stay curious. Keep learning about hydrogen energy and how underground storage works. The more you know, the more you can share with others, right? Tell your friends, family, colleagues, everyone.
Right, because before we can do anything, we need to spread the word.
Exactly. You can also, get involved in pushing for policies that support clean energy, contact your representatives, write letters, support organizations that are, fighting the good fight for hydrogen.
And for those feeling extra motivated, you can even look into investing in companies working on hydrogen tech.
That's definitely an option. But even smaller things like, using energy-efficient appliances, driving less, it all makes a difference.
So true. It's all about taking action, no matter how big or small, to create the future we want to live in.
Couldn't have said it better myself. And hopefully that future is one powered by clean, sustainable hydrogen energy.
Well, on that note, I think we've reached the end of our deep dive into the world of underground hydrogen storage. Hope you've enjoyed the ride.
I know I have. It's been great exploring this with you.
And remember, the more you know, the more you can do. Stay curious, keep asking questions, and keep learning. Until next time, happy diving.
Stay curious, keep exploring, and join us next time for more groundbreaking research brought straight to your ears. Don't forget to subscribe and share, because science is meant to be heard.